through, let's see, pool number 4, question number 5. We got through, we made up our function, right, in terms of x. So we got through C, and we learned that the whole point of this project was to do a quadratic model, which is what we did here, right? A of x equals x squared plus 8x plus 15 represented our pool plus its deck. We learned that the factors actually became the dimensions of the side. I think that's where we left off, right? All right, so let's finish answering the questions. Evaluate, we just have to evaluate what we chose for x. Now, if you chose the same number, x equal 2, you're just going to put in a of 2, right? And they want us to find p of 2 and the d of 2. And you guys are going to put in whatever you chose for x, whether it's 2, 4, 3. And so this is part D. This is pool number 4, question number 5. Okay, so the a of 2 for me is 2 squared plus 8 times 2 plus 15. It really should match up with our numbers, right? Let's see, 4 plus 16 plus 15 gives me 35 square feet. And then p of 2, let's see, p of x is x squared, so this is 2 squared, which gives us our 4 square feet, right? And then the d of 2, our deck, what? Excuse me, we're learning here. You're being disrupted. Okay, the d of x is 8 times 2 plus 15. That'd be 16 plus 15 is our 31 square feet. All right, I think with question number 5, they had started asking a couple of more things, right? So E, it says find the vertex. E, we have to find the vertex. Does anybody remember how to find the vertex of a quadratic? There's quite a few ways. Of course, I'm always going to show you the hard one, right? Because I think the harder it is, the funner it is. Okay, and now we're in standard form here, right? Y equals ax squared plus bx plus c. To find the x-coordinate of the vertex, we have a formula, negative b over 2a, right? So in our case, my b is 8, so I have negative 8 over, my b is, so I got negative 8 over 2 times a, which is 1. So I have negative 8 over 2, which equals negative 4. So that's the x-coordinate of the vertex, right? Where did I get 1? That's my a. Coefficient of x squared, right? Okay, so that's my x-coordinate of the vertex. How do I get the y-coordinate? I gotta do something. Well, I know x is negative 4, so actually I could plug in negative 4 for my x, right? So I'm just gonna put y in for the a of x. So y equals negative 4 squared plus 8 times negative 4 plus 15. My y-coordinate's going to be, let's see, 16 minus 32 plus 15. That's going to equal negative 1. So my y-coordinate's negative. There's my vertex. Anybody remember the easy way of doing it? I'm sorry, I'm not going to tell you. All right, let's see, what else? Y-intercept. Y-intercept. What does that mean? Yes, where it crosses the y-axis. So if I'm looking at a graph, let's see, let me just put a graph here. I think we have to graph this anyway, don't we? Yeah, we have to graph this anyway. So looking at a graph, I'm looking at this graph. Here's my x, here's my y. I got this parabola, and it crosses this y. Say it crosses here. I don't know if it does or not. What's my x value here? That's y value, but what's the x? 0. Yeah, y-intercept, the x equals 0. So what could I do for my equation here? I can find the y-intercept. This time, yeah, I'm not going to use the negative 4. I'm going to use 0. So this is when my x equals 0, right? So I'm going to use the same thing, but instead of negative 4, I'm putting in 0. Y equals 0 squared plus 8 times 0 plus 15. So what's my y-intercept? 15. Hey, what else we got to do here? Find the roots by factoring. Well, we already factored this, right? And C. So it's factored. A of x or y equals x plus 3 and x plus 5. For the roots, what do we do? Roots, solutions, zeros, whatever you want to call them. We set each one equal to 0, right? Mm-hmm. So x is going to equal to negative 3 and negative 5. So there's my roots. Okay, what else? F is just the graph. There's F. So this should be easy because I have the vertex, negative 4, negative 1, right? So negative 4, negative 1. And then the roots, or the zeros, or x-intercepts, negative 3 and negative 5. I got 3 points. That should be enough to get me my parabola. And there's my graph. And I don't think I used my calculator, did I? For this entire problem. So what would be a shortcut? Use your calculator, right? Any questions? So this is going to be for the rest of the pools, pools 5 and 6, and then for your quiz part that you were supposed to do last week, that we haven't done yet. Do you want me to do one more pool? Okay. Are you ready, Freddie? So this is pool number 5. We're on question 6. Okay, 6A. First thing we have to do, draw our pool. Now this one's kind of strange. I actually did this wrong the first time because the dimensions were kind of in a weird spot. So it looks like we have a 3 by 4 foot pool. I'm going to draw a 3 by 4 foot pool. 1, 2, 3, 4. 3. 1, 2, 3, 4. And 3. So this is 3 by 4, right? And it says we have a deck going completely around this pool, and its length is 2. I'm gonna. Oh, did I say 2? I'm gonna choose 2 for my x. I'm sorry. It's x length. So I don't know. I'm just gonna draw a square around a rectangle around the rectangle. Okay. Now this distance from the edge of the pool to here is x distance. So this is x by x. It's square. Okay. So every corner is going to be x by x. You're getting ahead of me. Yep. It's going to be the area is x squared. Each one of those is x by x. Okay, so again, we might as well put all the dimensions on there because eventually we're going to use all the dimensions in our, 1 through F, the questions. So let's do it in terms of x first. So in terms of x, we've got the x squared, right? X times x squared, right? Now, this rectangle here, let's see, we're only looking at this rectangle there, right? What's the area of this rectangle? Not plus 4. Yeah, 4x, right? One's 4x. Again, this is x times x, so this area is x squared. This rectangle is going to be 3x. Good. 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 So in terms of x, there we go. Now, you can use whatever number you want. Again, I'm going to choose x equal 2. Okay, if I were to do this numerically, what's the area of this corner? 4. What's the area of this rectangle? Careful. 8. Okay, and then this would be 4. This would be 6. Good. 4, 8, 4, and 6. So we have it in terms of x's and we have it in terms of numbers. All right, so B see, find the total area, and this time they wanted in numbers, right? Tell me if I'm going too fast. You know if I'm going too fast. Okay, this is x by x. That's an x squared. In terms of x, that's my area, x squared. And in terms of the number, because I chose 2, 2 squared is 4. I just picked 2. You can pick any number you want. Okay. All right. So question B. We need to find the total area. How'd you find the total area? What numbers? Wow, 4 plus 6 plus 4 plus 8 plus 4 plus 6 plus 4 plus 8. And what'd you get? I know. But you know me, I like to make things fun. Fun. Okay, now what? They want pool area. What is it? How'd you get 14? Oh, okay. 2L plus 2L. Or you could just take 3 times 4, right? 4 plus 6 plus 4 plus 8 plus 4 plus 6 plus 4 plus 8. I just went around here and added all of the numbers to the composite figures that we did on day 1 of semester 1, right? Remember we had that worksheet where we were trying to find, what's that? Yeah. Remember we had all kinds of weird shapes, and we would make a rectangle or a triangle, then we would figure out the areas, then we added them together. That's exactly what we did here. Okay. So the pool area, well, this is just length times width, which is 12, right? So the pool area, 12 square feet. And what else they want? Deck area. Well, again, I mean, there are shorter ways of doing this, but for teaching purposes, I'm going to add up the deck. 12, 24, 30. You sure the total area is 44? What about the pool area? Oh, okay. So we got to add 56 to this, right? No, I mean 12 to get 56. Now I messed it up. Wow. Yeah, doesn't take much to mess me up. And here we go. It's the pen's fall. Yeah. So plus 12. So that gives us 56 total square feet, right? Okay. The deck area is 44. Okay. That's all of these numbers added together. Okay. We got all of B. C, write it in term. We got to write the functions in terms of X. Again, we need the total area, the deck area, and the pool area. What's the function of the pool? What's P of X? Do we have any X's in for the pool? No, it's just a constant, isn't it? So we really don't have we do have a variable, but it's to the 0 power. Okay, so the pool is going to be 12. And what's the deck area in terms of X? Help them out, guys. What's the total? How did we find the area of the deck? No, not the corners. We added well, we did add the corners. How many corners do I have? So how many X for what? I have 4 of the X squares plus how many of the X's? Huh? Well, how many X's do I have? Single X's, X to the first. I have 4 here. I have how many there? 3. So I have 4X plus 3X plus another 4X and another 3X. So how many total? 14 X's. Yep, we're adding up. Yes, Evan. Yeah. Well, each corner is X squared. So there are 4 areas of X squared. So I could just take, what I'm doing is I'm taking X squared plus X squared plus X squared plus X squared. Shorten it, and I shortened it up to saying, well, it's 4 times X squared. Okay. Now, so the total area, we're going to add all of these together, right? Okay, for the total area, we're going to add the deck and the pool. You got it. Okay. Now, let's factor this. Let's factor this. Good. Awesome. First thing we have to do is take out a 2. Step 1, take out any common terms, right? So I have 2x squared plus 7x plus 6. Can I factor that? Yes. There's only one way to get 2x squared, right? 2x and x. Okay. Only one way to get multiply to a positive number and add up to a positive. Both of these have to be positive. Okay. Now remember, one of the factors of 6 is going to be multiplied by 2. So if we use 2 and 3, we want the 2 to be multiplied by 2 to get 4. Then we're going to add the 3, which gives us the 7. Okay. We know that the 2x plus 3 and the x plus 2 are going to be the dimensions, overall dimensions of my pool. Which one's which? Okay. If I look at the length here, well, the total area, okay? The total area here for this length is 2x squared plus 4x, right? Okay. If I took out the common term, 2x, what do I have left? X plus 2. Look at that. X plus 2, X plus 2. This is just it's a It's just like a number that's being multiplied. It's like the slope. Okay. So let's look at the other dimension here. Okay. So if I were to add these up, I would have 2x squared plus 3x, right? I got 2 of the x squared plus the 3x. Again, I can factor out a x. I end up with 2x plus 3. There's my other factor. Okay. So my length is the x plus 2, and my width is the 2x plus 3. Okay? Again, that's the whole point of the project. Come up with a mathematical model to represent a situation. Okay, D. D is just to confirm everything. Okay, so I got to find the A of 2, the D of 2, and the P of 2. Okay, A of 2, I have 4 times 2 squared plus 14 times 2 plus 12, and I better get 56. See, 416 plus 28 plus 12 is indeed 56 square feet. D of 2, they have 4 times 2 squared plus 28 again. So 16 plus 28 is our 44. And then nothing changes with the 12. So far, so good. And then E's got all this extra stuff, right? The vertex of the vertex of 4x squared, so I've got to do x equals negative b over 2a. My b is 14. 2 times my a is 4. So I have negative 14 over 8, which reduces to negative 7 over 4. So I have negative 7 over 4. Oh, boy, is this one going to be fun. Boy, oh boy, I can't wait. I have y. I got to find my y, right? So for x, I'm going to plug in negative 7 4. You talk about fun math. 4 times negative 7 fourths squared plus 14 times negative 7 fourths plus 12. I would plug that into a calculator. Nothing's more than fractions. Oh, negative, there you go. Negative 7 divided by 4 squared plus 14 times negative 7 divided by 4 plus 12. And since we're dealing with fractions, we'll keep it fractions. Negative 1/4. Okay. There's my vertex. Now, what else we need? Y-intercept. Oh boy. Y-intercept not x equals 0, right? So instead of negative 7/4, we just put in 0. So y equals 4 times 0 squared plus 14 times 0. So what's the y-intercept? Hey, what can we just do whenever we're figuring out the y-intercept in a quadratic equation? Yeah, it's the c. So there's an easy way to find the y-intercept. Okay, what else do I got? We just got to graph it. That's it. Oh, roots. Root. The roots. See, we have our factors, right? 2x plus 3, and the other root, x plus 2. So this is going to be subtract 3, get 2x equals negative 3, divide by 2, divide by 2. X equals negative 3 halves, and negative 2. Hey, we got plenty of stuff to graph this now. Wow, what an ugly graph. Okay, my roots. Let's start with the roots. Negative 2, negative 2, negative 1.5. So this is going to be a pretty narrow problem. What's my vertex? Almost negative 2, down a quarter, somewhere around there. We have a y-intercept of 12, so way up here. So this could be a pretty skinny parabola. There we go. Ugly axis, but my graph is nice. And there you have poll number 5. Question number 6. Now, your quiz. All you have to do is start on with number 5. In fact, we did this one. That's poll number 5, right? So start with this one. Guys, don't find the slopes, okay, because these are nonlinear slopes. We don't need it this course. No, just the slope, yeah. Okay, don't find the slope. I think there's another question that says find the slope. Yeah, wherever it says find slope, ignore. Okay. But now you have enough. I think you guys have enough to get through those. Okay. So between today and tomorrow, can we finish up? Right? Huh? Yeah. Well, we only have 6 minutes. I don't know. What time?